Hello. Good evening, students. Am I audible? Good evening, students. Am I audible? Hello. Can someone respond whether I'm audible or not? Hello. Yeah. Students, are you able to hear me?
Yes, sir.
Good. Okay. So we'll get started. What was the last topic we were seeing yesterday? We were discussing about torque and moment of inertia, right? So I thought we'll do some problems today. Okay. So to begin with, we will start with this. Find the torque of a force of value 7i cap plus 3j cap minus 5k cap about the origin. The force acts on a particle whose position vector is this much value. Okay. So how to calculate the torque? What is the formula for torque? Torque vector is equal to r vector cross f vector. So r vector is this thing. F vector is this thing. Calculate it fast and tell me what is the value. Do it fast. Anybody with the answer? So what is the answer, guys? Make it fast.
Minus 2i cap minus 12j cap plus 4k cap.
I think there is no minus I, minus 2. I think you made some mistake.
Yes,
Did you
sir,
do?
yes, sir. I will
Ah. So it is 2i cap plus 12j cap plus 10k cap. So that is the value. Since they have not given the units, let's not worry about it. Okay. Next is so listen. We will do this problem. There's a slightly tougher one. Okay. I will be doing this problem, but you guys concentrate. Okay, listen. There is a metal bar which is 70 centimeter long, means the length is 70 centimeter or 0.7 meter, and mass is 4 kilogram. Okay, it is supported on two knife edges K1 and K2, which are placed 10 centimeter from each end. So this is 10 centimeter and this is also 10 centimeter. Okay, so there is a 6 kilogram load that is suspended at 30 centimeter from each end. There is a 6 kilogram load that is suspended at 30 centimeter from, sorry, not each end, from one end. Okay, find the reactions at the knife edges. Assume the bar to be of uniform cross section and homogeneous. Now see, listen to this carefully, guys. So they told 30 centimeter from one of the ends, right? This is going to be 30 centimeter because G is the point of center of gravity. So center of gravity for a 70 centimeter rod, uniform rod, will be at which point? Will be exactly at the center at a value of 35 centimeter. Correct? Right? Now tell me one thing, guys. If this whole system has to be at equilibrium, means if it should not rotate, then what are the conditions that need to get satisfied? For the system to be at equilibrium, when I say equilibrium, it has to satisfy both translational and rotation. Correct? So it has to satisfy both translational and rotational. So observe. So in both the cases, acceleration should be zero. That is the meaning of equilibrium. If my voice is breaking at any point, now I want to know immediately. So for translational equilibrium, what should happen? You guys tell me. So for translational equilibrium, apply Newton's third law. Sum of upward forces should be equal to sum of downward forces. Okay. So what are the sum of upward forces that are acting? R1 and R2. Am I right, guys? Yes or no?
Yes, sir.
Okay. So R1 plus R2 is balanced by which other force? Who is balancing this force? It's simple. Look at the diagram, you'll get the answer.
Center of mass, sir.
Sorry? I think you're right. Please tell me
Center of
confidently.
mass, sir.
Yeah. It is the weight of the rod which is acting at the center of gravity. And what does W1 stand for? W1 stands for the weight of the load that is suspended. How much is the load that is suspended? It is 6 kilograms. So R1 plus R2 is balanced by 4 plus 6 into, I'm taking G as 10 for the time being. So this will be equal to 100. So R1 plus R2 is equal to 100 newtons. Is there any doubt in this step?
Yes, sir.
Okay. Please make a note of it. This is for translational equilibrium. Now we will do for
Sir,
Tell me.
Sir, could you show the diagram once? Sir, here won't there be a tension because of W1? I mean, yeah.
There is no tension. No tension will come into picture only if it is a string. It is not a string. It is a rod, metal. So rods will generally exert or experience normal forces. There is no concept.
Yes, sir. Sorry, normal forces. Yeah. So won't there be a normal force acting upwards?
R1 and R2 are the normal forces. Right? Find the reactions and ripple. So these reactions, what they're trying to talk about is the normal force. So that is our job.
Okay, sir.
Got it? Yeah. So for rotational equilibrium, what am I supposed to do? See, whenever you're doing this kind of a problem, right? Whenever you're trying to solve a problem based on rotational equilibrium, you need to mention about which point, because rotation will happen about an axis, about point G. Okay. So what we will do is we will try. I'm going to ask you some questions, and you guys are going to answer it. So only two options that you will have is either clockwise or anti-clockwise. So about point G, listen to this carefully. About point G, first of all, look at the diagram. Okay, in this diagram, in this situation, how many forces are you able to see? In this whole diagram, how many forces are there? R1, R2, W, W1. So there are 4 forces, sir. Am I right? So out of those 4 forces, the one which is passing through the point about which you're trying to calculate the torque, okay, point about which you're trying to calculate the rotation, whatever is a force acting through that point, it will not contribute to any torque. Means W will not be responsible for this object to rotate at all. You remember, center of gravity is the point where the object will not experience any torque. Correct? Now, what about R1? So R1 will try to put the object in which direction of rotation? About 0.4. R1, R1 has a tendency to rotate the object in the clockwise direction. Means if I apply a force in this direction, then this rod will start rotating in the clockwise direction. Similarly, at knife 2, if I apply a force, that will tend to rotate the object in the anti-clockwise direction about 0.4. Correct? Now, what about W1? So if I apply a force in this direction, in which direction will the object tend to revolve?
Anti-clockwise.
It is
Anti-clockwise.
Anti-clockwise. As simple as that, right? Now the question is, when I say for translational equilibrium, sum of upward forces is equal to sum of downward forces. For rotational equilibrium, I will say sum of clockwise moments should be equal to sum of, please write it down, sum of anti-clockwise moments, and this is called as the principle of moments. Okay. This is called as the principle of moments. So if someone asks you, what is the statement of principle of moments? Sum of the clockwise moments is equal to sum of the anti-clockwise moments. That's it. Now tell me, what are all the clockwise moments that are possible on this object? So which forces are putting the object into clockwise rotation?
Only R1.
Okay. So you're calculating the moment about point G. So from R1, what is this perpendicular distance? That is the critical point that we need to calculate. See, this distance is 30, correct? According to the question, read it carefully. Where is the knife placed from the end? It is at a distance of 10 centimeter. And how much will this distance be? It will be 5. So how much will be the distance between K1 and point P?
20 centimeters.
It should be 20. Yeah? No. I'm sorry. K1 and G, because you need the distance from K1 to G, no?
Yes, sir. So it will be 25.
25 centimeter. So R1 is a force which is acting at a distance of 25 centimeter from point G. So clockwise moment is, can I write it as R1 into 25 is equal to, what are the anti-clockwise moments? R2 and the distance between K to G, correct? Tell me.
So it will still be 25 only.
It is 25. Now what about W1 and W? That is already known. It is 5. Right? So can I write it as W1 into 5 plus R2 into 25? Is there any doubt, guys? This is a very, very important step. If you don't understand this, you can't solve any of the previous other problems. R1 into this thing. So 5 will cancel this out. This will be 5. This will be 5. So 5 R1 is equal to W1 plus 5 R2. 5 into R1 minus R2 is equal to W1. But what is W1, guys? W1 is the weight of 6 kilogram object. So it should be 60. So I will cancel this. It will become 12. R1 minus R2 is 12. And R1 plus R2 is 100. Can you calculate the values and tell me? Cancel it. 2 times R1 is equal to 112. Then R1 will be equal to 56. And R2 will be how much? So our job is done. They asked us to calculate the reactions offered by the knife and we calculated it. That's it. Please write it down.
Sir, could you show the diagram once?
Sorry, what did you ask? You want me to show?
The diagram, sir.
1 minute, wait. Yeah.
Will there be any normal force?
No, normal force is only R1 and R2. Normal force is only R1 and R2. That is the reaction. Normal is the reaction force, right? It's not an action force.
At point P, won't there be any normal force?
No, because there is no object in contact. No? It is only weight that is suspended. Here the normal force are coming because one solid is in contact with another solid. Here what is the force? Normal is a contact force. What is the force that is acting here? Nothing. Just a mass is suspended. So at that point, it is only the weight of that mass that is suspended is responsible for its force.
Okay, sir.
Okay. So if you have this, if you guys have completed this, let me know.
Sir, I have a doubt.
Guys, are you done writing it?
Sir,
Tell me.
sir, I have a doubt. Like suppose before the object was suspended, the center of mass was point G, but now since the object is suspended, the center of mass will change, right?
No, no, no. Center of mass of the rod is still the same. You're talking about the center of mass of the system. Okay. So the point G will still be the center of mass or center of gravity for the rod. That will not change. But the rod plus the load, yes, that will change. But that is not our concern with respect to this problem, at least. Our job is only to understand what are all the reaction forces that is going to act on this so that the whole system is at equilibrium. If they want, they can suspend even 10 masses here. That is their headache. Even this is going to happen. Yes, to answer your question, center of mass of this whole system will change, but the center of mass of the rod will still be at G only. Try to understand that. Think about it.
Okay, sir, got it.
Got it? Yeah. Now the question, I will do a similar problem. Okay. The next example is also there, but that is slightly tough. There'll be a problem based on a car. This one, 7.9. I want you all to try this. Okay. So there is a car which weighs 1,800 kilograms. So the mass of the car is given. The distance between the front and the back axles is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. Determine the force exerted by the level ground on each front wheel and each back wheel. Okay, it's an interesting problem. Mark it as important. So there is a car that weighs 1,800. So the front wheel and the back wheel are there. And let's say the weight of the car is 1,800 kilograms. So where will the 1,800 kilogram act? Exactly at the center. So 1,800 into 10 is the weight of the car. Okay, let me write it as W. Right. The distance between the front and the back axle means the axis of that particular vehicle, is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. Okay, this is the center of gravity. This distance is how much? 1.05. So how much is this distance, guys? So how much is this, guys?
0.75.
That is 3/4. Right. Now, there will be a normal reaction offered by the front wheel, which I'll call it as N1. There will be a normal reaction offered by the back wheel N2. This is by one of the front wheels and one of the back wheels. But what will be the number of normal reactions due to the front wheel? See, listen, N1 is normal reaction by one front wheel. N2 is the normal reaction by one back wheel. Okay. So what is the total normal reaction acting? What is the total
2
normal?
into N1 plus N2.
Very good. So 2 times N1 plus N2 is balanced by whom?
The weight.
Perfect. So for translational equilibrium, this is the only difference, okay, compared to the previous problem. Can I say 2 times N1 plus N2 is equal to W? Right. So 2 times N1 plus N2, W is 1800 into 10. This will go 900 times. So this was going to be 9000 Newton. So N1 plus N2 is 9000. Am I clear? Right. So compared to the previous problem, this problem is even more simpler. So if I take this point as G, tell me one thing, guys. Due to N1 about point G means if you apply a force in this direction, the car will tend to rotate in clockwise or anti-clockwise direction.
Clockwise.
Perfect. Due to N2, if you apply a force in this direction, it will tend to revolve in the anti-clockwise direction. Okay. So can I say for rotational equilibrium, okay, so can I say for rotational equilibrium, whenever I told about rotational equilibrium, we need to mention the points, no? Rotational equilibrium about point G. Can I write clockwise moments is equal to anti-clockwise moments? Okay. So what is the clockwise moment that is acting? N1 multiplied with how much is the distance, guys? What is the perpendicular distance? I asked a very simple question. What is the perpendicular distance between N1 and G?
1.05.
That's it. So N1 into 1.05 should be equal to N2 into 0.7. Correct.
Sir, so we don't write 2 because it gets cancelled.
Yeah, we don't write it. Right. So can I write N1 into 105 is equal to N2 into 75, multiplying with 100 on both the sides. So 105 and 75 both I think are divisible by 15 itself. This will go 5 times. This will go 7 times. So 7 times N1 is equal to 5 times N2. Equation number 2. Take this, substitute it in equation number 1. I'll give you 2 minutes time. Calculate the value of N1 and N2 and tell me.
Sir, N2 is 5250 and N1 is 3750.
N2 is 5250, N1 is 3750. Yes. So what did they ask in the question? Determine the force exerted by the level ground on each front wheel and each back wheel. So since you are using the word each, you should stop it with N1 and N2. Okay. If they ask what is the total force exerted by the front wheel, then you need to write 2 times N1. So be careful with that.
Sir, so the normal force exerted by one wheel is 5250 in case of
Yeah,
back
one
wheel.
of the back wheels is 5250. By 2 wheels put together into 2. Okay. So I hope you guys are a little bit confident with this. First, we'll master this method. Then we can go to the next concept. Okay. So try this problem. 7.17. So a meter stick is balanced on a knife edge at its center. When 2 coins, each of mass 5 kilograms, are put one on top of the other at 12 centimeter mark, the stick is found to be balanced at 45 centimeter. What is the mass of the meter stick? How to do? You guys first try to draw the diagram, then I will draw. See if that is matching with the concept you thought of. So meter stick is balanced on a knife edge at its center. So the meaning of meter stick is the stick is of length 100 centimeter or 1 meter. Okay, is balanced on a knife edge at the center. Okay, when 2 coins, each of mass 5 kilograms, are put one on top of the other at a 12 centimeter mark. So here, let's say it is 12 centimeter mark. One coin here and another coin here. If they are put like this, then this knife gets shifted to a position where the reading says 45 centimeters. Am I clear? Right. Now our job is to find the mass of this meter stick. How to proceed?
Sir, we can use using the rotational moments.
That's it. That is the only option, right? So the weight of the rod will still act at its center only. Correct? The weight of the rod is still going to be at center. You had to move this knife to the left only because there were some masses placed on top of it at a distance of 12 centimeters from the origin. So W is still acting at its center. That is the meaning why they gave the statement meter stick is balanced on a knife edge at its center. Means they are trying to say it is having uniform mass where the whole mass is said to be concentrated at its center. Then what will be the distance between the position where between the center of gravity and the new balance point? It is 5 centimeters. Correct?
Yes, sir.
Okay. Now, the weight of these two coins will act in this direction. How much is that? It is 10 grams. So, 10 into 10 power minus 3 into 10. So, due to the coins about this knife. So, can I say if this has to be balanced, then it is at rotational equilibrium. So, when it is at rotational equilibrium, you are free to choose any point. In this case, what are we supposed to do? Rotational equilibrium about which point shall we take? About the knife is given something like this. Clockwise moments is equal to anti-clockwise moments. So which one is responsible for the clockwise moment about the balance point? Tell me. Is it W or the weight of the coins?
Weight of the coins.
Weight of the coins will put it in anti-clockwise. So if you apply force in this direction about the knife edge, it will revolve in this direction. It is anti-clockwise. So in this direction, it will be clockwise. Okay. So clockwise moment is weight of the object into 5 is equal to anti-clockwise moment is 10 into 10 power minus 3 into 10. That is weight of the coins into the distance. How much is the distance? Tell me. Let's see how much you understood. What is the distance between the weight of the coins and the knife edge?
Sir.
Mm-hmm.
So the normal force acting on the coins is also like.
No, normal force here we are not taking because it is very, very small. It is negligible. The reason is they are only in terms of grams.
Okay, sir.
So 10 into 10 power minus 3 into 10 is the weight of the coins. Force multiplied with perpendicular distance. What is the distance between the coins and the knife edge?
33 centimeters, sir.
How much more? Correct, correct. How much is it? 30?
33.
Very good. So it is 33 centimeters. So this will cancel it 2 times. So 2 into 33 is 66 into 10 is 660 into 10 power minus 3 kilogram. Sorry, Newton. Okay, weight is mass into 10. So 10 and this will get cancelled. M will be equal to 66 into 10 power minus 3 kilogram. 66 into 10 power minus 3 kilogram is 66 grams. So the mass of this scale is exactly 66 grams.
Sir.
Tell me.
Sir, if you're considering the weight of the coins, then why aren't we considering the normal force of the coins?
No, we may not take it, no. See, if you take both, are you trying to say that they are under translational equilibrium? See, if the weight is going to be like this, the normal force will be like this. And secondly, what is happening is, okay, try to understand in the previous case, what happened? If the knife edge is there, here there will be a normal force which will always be in contact. Okay. If I have to speak about it practically, I'm not sure if you visualize this, but I'm going to tell you something. Listen. These coins are there, right? These coins will put this object into revolution and they will lose contact at some point. I told you normal is a contact force. They will lose contact with whom? With the scale for some time. So it is not going to be exactly the same. So that's the reason why we are not taking the normal force into consideration in this scenario. Whereas you can ask me in the previous problems you took because they are constantly in contact with the surface. So this is going to be 66 grams. See, that is one way of looking. If I have to give you another perspective, can I say that the mass of this whole rod is concentrated at this point? Mass of the whole meter scale is concentrated at point G. So if I take the knife edge exactly at a distance of 45 centimeters from the origin, I can treat as if there is a point mass whose weight is acting here. And you can forget about the scale. Then you can say that there is another point mass, which are nothing but 2 points, which I'll call it as W1, that is acting here. If I take this kind of a scenario, do I need to take the normal into consideration?
Yes.
So, whereas in other problems, right, you might get doubt, why did I take it in the other problems? You see the other problems, if suppose here, we are supposed to take the normal force into consideration because the knife is in constant touch with this. Right? So that's what is happening. That is the reason. Think about it, you will understand it slowly. Okay. One last problem based on this. You try this, no? 7.8. So there is a non-uniform bar of weight W that is suspended at rest. So whenever you see at rest, it is a translational as well as a rotational equilibrium. Okay. So they are suspended by 2 strings of negligible weight. The angles made by the string with the vertical are 36.9 degrees, which can be approximated to 37 degrees, and 53.1 degrees, which can be approximated to 53 degrees, respectively. The bar is 2 meters long. Calculate the distance D of the center of gravity of the bar from its left end. See, if it is a 2 meter rod, where should have been the center of gravity?
At 1 meter from the
1
end.
meter, right? So can I say that D is exactly equal to 1 meter in this scenario? Simple, right?
No, sir.
But you can't say. Why?
Sir, because it's the strings are like handed different angles.
It has nothing. See, I repeat it again. You talk about the center of gravity of a particular object. You should not take any other object into consideration. It has nothing to do with string. But your answer knows right. I want a right validation. It has nothing to do with string. It is purely because D would have been 1 meter had it been a uniform rod. Whereas in the question, they have clearly mentioned it is a non-uniform bar. Okay. Non-uniform means the bar can be like this. You're able to understand it has some irregular shapes, or there can be uneven distribution of mass. When that kind of a thing happens, we know the fact that within the system, the center of gravity will be closer to the point with greater mass. You're able to understand what I'm trying to say. That is why in this case, the answer is not 1 meter. Rather, we are forced to solve this. Am I clear with that point? Shall I proceed? Listen. So let's say this string has tension T1. This string has tension T2. Okay. Now, this T2 can be resolved into 2 components. What are they? If this is 53 degrees, this is also 53 degrees. How much will this be? This will be T2 cos 53 degrees, and this one will be T2 sin 53 degrees. Similarly, T1 here, what will happen? This is 37, this is also 37. It will be T1 cos 37 degrees, and this one will be T1 sin 37 degrees. Now tell me, for translational equilibrium, what are all the forces that are balanced? T1 cos 30 plus T2, sorry, cos 37. T1 cos 37 plus T2 cos 53 degrees is balanced by whom? So T1 cos 37 and T1 cos 53, they are acting in which direction?
Upwards.
So what should be the downward one?
The weight.
That's it, is equal to W. Similarly, this is along Y direction. For X direction, T1 sin 37 degrees should be equal to T2 sin 53 degrees. Correct? Right. Now, if I say this point is G, can I say for rotational equilibrium about the point G, can I say clockwise moments is equal to anti-clockwise moments? Now tell me which force is responsible for clockwise moment. Which force will tend to put the object?
T1 cos 37.
Very good. So T1 cos 37 multiplied with, what is the distance between T1 cos 37 and center of gravity?
D.
T1 cos 37 into D should be equal to, what is the other force which is causing the anti-clockwise moment? It is
T2 cos 50.
T2 cos 53 multiplied with 2 minus D. Correct? So how many unknowns are there? 3 unknowns, 3 equations. Can you guys solve this? Okay, I'll give you 2 minutes time. Solve and tell me what is the answer. Do you guys know what is sine 37? Sine 37 is 3 by 5, which is the same as cos 53 degrees. Similarly, sine 53 degrees is equal to cos 37 degrees is equal to 4 by 5. These are the values. Take it, substitute it there, and tell me what is the answer. Do it fast.
Sir, what is the mass of the rock?
Mass.
What is the mass?
They told it is W only, no? They didn't give any mass. It is W, that's it. How can they not give a value of weight? And our answer should be in terms of W only. Okay, actually, a mass is not needed because see, T1 into 4 by 5 is equal to, sorry, 3 by 5 is equal to T2 into 4 by 5. So 3T1 is equal to 4T2, correct? So T1 will be equal to 4T2 by 3. Take this and substitute it here. Now T2 will get cancelled. Cos 37 is 4 by 5 into D is equal to T2 into 3 by 5 into 2 minus D. So T2 and T2 will get cancelled. 16D divided by 15 is equal to 6 by 5 minus 3D by 5. Or I can write 9D by 15. So 25D by 15 is equal to 6 by 5. This will go 3 times. So implies D is equal to 18 divided by 25. So these many centimeter is the answer. Centimeter, it is meter. 18 divided by 25 should be 0. If I'm not wrong, 25 tenths is 250. 25 6 is 150, 150, 175. So 0.7 something. Okay. I hope it is clear. 0.7. I don't know what is the next number. Goes to the meter. So it is not exactly at 1
Sir?
meter. Tell me.
Sir, I'm getting a 6 by 19.
6 by 9.
No, sir, 6 by 19.
Your voice is breaking again. 6 by 19.
Yes, sir.
I don't think so. What I remember, I think 0.7 something. Yeah. If you have a textbook in your hand, please check the answer. No? I think it is 0.7172 something. Please check. No. Did anyone check that? Okay. Why is no one else responding? Others, are you there, or you have put just switched it on and you're sitting for the sake of it? Respond.
Yes, sir.
0.7 something, right?
It's 7.2, sir. Yes, sir. 0.7.
0.72. That's right. Yeah. So 18 divided by 25 meter is the answer. It is not 1 meter. So since it is 0.72 meter, more mass is concentrated on the left. So that is another analysis we can do. Okay. So this is all about problems based on the equilibrium. Okay. Next class, we will be discussing about the moment of inertia based problems. Okay. See guys, mostly I'm not there tomorrow. Okay, I have some personal work. I'll not be available, so I might not be able to take tomorrow's class. The next class will be on Monday. Physics class alone. Okay. So that's it from my side. If you have no doubts, we can wind up.
Sir, I have no doubt, but I was actually marked absent today in class. Yeah, I
Okay.
actually joined late, sir, so I had school till 4:15.
Okay, that's fine.
Yes, sir.
Okay. Yeah, we can wind up, guys. There are no more doubts.
Okay, thank you, sir.
Thank you, sir.